In this video, discuss the methods of finding the exact values of some trigonometric functions for given angles. Now, angles are specials. So, therefore, for all special angles, we can provide the exact values of the trigonometric functions. Now, special angles are taken from the one that is the isosceles right triangle. For an isosceles right triangle, we have the 45 by 45 and 90 degrees. So, for example, this is a triangle. The two angles must have the same value, and that is 45 and 45. So, we call this as the isosceles right triangle. This is a special triangle. Hence, the angles are special. So, therefore, we can provide the exact values of the 6 trigonometric functions of the 45 degrees. The 6 trigonometric functions are the primary, the sine, cosine, and tangent. And we have the secondary functions, the cofactors or the reciprocals of the primary. We have the cosecant, secant, and cotangent. So for a given isosceles right triangle, then it follows that we have, since we have two angles are congruent, then it follows that the sides also must be congruent. Now remember that the angle or the side opposite to the 90 degrees is always the hypotenuse of the right triangle. So using the Pythagorean Theorem, we can provide the hypotenuse as the square root of 2. Take note, Pythagorean Theorem means the square of the hypotenuse is equivalent to the sum of the squares of the two sides. So, applying the principle, this hypotenuse is equivalent to square root of 3. Now, remember that there are two measures of the angles. It can be a degree or a radian. So, for the 45 degrees, it is equivalent to pi over 4. It's because that 1 pi radian is equal to 180 degrees. So therefore, if we have 45 degrees, it is equivalent to pi over 4 radians. So using the Sukatua principle or the strategy of finding the primary trigonometric function, the sine, cosine, and tangent, so represent the sine opposite is divided by the hypotenuse, while c corresponds the cosine, and this is equal to adjacent over the hypotenuse side, and t represent the tangent, which is equivalent to opposite over the adjacent side. So for example, we want to calculate how much is the sine of 45 degrees. Then if suppose this is our angle 45 degrees, then sine is means sine function is equivalent to opposite. The opposite of this side is 1. So this is the opposite side, while this one is the hypotenuse side. So opposite over hypotenuse is sine. So it should be 1 over square root of 2. Okay? So then rationalize. Then we have the square root of 2 over 2. This is the exact value for the sine of 45 degrees. Then for the cosine, take note that if we have this angle again, the cosine of this function is actually the opposite, because from the coding of the primary function, we have the cosine is equivalent to adjacent over hypotenuse. In this case, we can call this as the adjacent side, and again this is the hypotenuse. The hypotenuse side is always opposite to the 90 degrees. So since this 90, it is always the hypotenuse. Now the adjacent and opposite depends on the deciding angle. So if you decide to have this, then this would be our adjacent. Okay, then opposite to that is the opposite side. Now, if you choose this angle to be your angle, then the opposite, this side is considered as the opposite, while this one is the adjacent. But the hypotenuse is always the same. Okay, so for the cosine, we have the adjacent over hypotenuse is 1 over square root of 2. Then rationalizing, we have square root of 2 over 2. This is the cosine function, the exact value for the cosine of 45 degrees. Now, for the tangent, take note the tangent is opposite of hypotenuse, so we have to 1 divided by 1 divided by 1 is the same as 1. So, these are the primary trigonometric functions: sine, cosine, and tangent. Now, the reciprocal of sine is cosecant. So, the cosecant of 45 degrees is the reciprocal of the sine function. So, we have to reverse this one. The 1 over square root of 2 is equivalent to square root of 2. So, this is the exact value. Now, take note, our calculator will provide an approximate value, but this one is the exact. Okay, so we are able to find this answer. It's because of the principle of the special triangle, which is isosceles right triangle. So again, since the reciprocal of cosine is secant, then you have to reverse this one and the same as square root of 2. Now for the tangent, the reciprocal of tangent, take note, is cotangent. So we have 45 degrees. The cotangent of 45 degrees is equivalent to 1. So these are the 6 trigonometric functions for the 45 degree angle. So we have to note that for a 45 degree, 45 by 45, or the isosceles triangle, the two sides must be congruent. So we can assign this as 1. So therefore, square root of 2 as the hypotenuse. Okay, so another special triangle is the so-called 30 by 60 right triangle, which means that in a triangle, one of the side is 60, the other is 30 degrees. Okay, so the principle says in a 30 by 60 triangle that the hypotenuse of that triangle is twice as much as the side opposite to the 30 degrees. So the side opposite to the 30 degrees, multiply it by 2, and that is the hypotenuse. Which means that if the opposite side is 2, multiply it by 2, the answer is 4. So for simplicity, we will assign this as 1, such that the hypotenuse becomes 2. Okay? Now applying the Pythagorean Theorem, solving for the other side. So remember that the Pythagorean Theorem means the square of the hypotenuse is equivalent to the sum of the squares of the two sides. So solving for this side, we will come up with an answer of square root of 3. So these are the important dimensions for the 30 by 60 right triangle. So therefore, this must be, the 60 degrees must be a special angle, and the 30 degrees is also a special angle. Now using these sides of this triangle, we can find the exact value of the 6 trigonometric function. Okay, now for the 30 degrees, remember is pi over 6. Pi over 6 is a 30 degrees. Now remember that 1 pi radian is equivalent to 180 degrees. Okay, so if you want to convert the 30 degrees, multiply it with the ratio of the equivalent. So we have this as pi over 180 degrees. Okay, so such that the degree will be cancelled out, and we have the unit as the radian. So reduce this one, 30 over 180 degrees. This is equivalent to pi over 6. and the unit is in radian. Okay, so therefore, calculating the primary of the trigonometric functions, applying the SOHCAHTOA principle. So means again the sine is equal to opposite over the hypotenuse. So since we are concerned with this angle, and this is 30 degrees, what are the 6 trigonometric functions of 30 degrees? Then this should be our adjacent side, while 1 is our opposite. And again, 2 is our hypotenuse, because the hypotenuse is always opposite to the 90 degree angle. So then, calculating the sine of 30 degrees is, take note, so means opposite. So we have to divide 1, and this is it, divided by the hypotenuse. Okay, so the opposite and divided by the hypotenuse sine. And the answer should be what? Should be 1/2. And this is the exact value. Now for the cosine, take note that cosine is adjacent of hypotenuse. So this is the adjacent, so you have to use it. And this one is the okay, this is the hypotenuse, which is 2. So square root of 3 over 2 is the exact value for the cosine of 30 degrees. Now for tangent, opposite over adjacent, remember that our opposite is 1, our adjacent is square root of 3. Then rationalize the denominator by multiplying square root of 3 over square root of 3, we come up with square root of 3 over 3. Okay, so these are the primary trigonometric functions for the angle of 30 degrees, or take note, pi over 6, which means that the sine of pi over 6 is also equal to 1/2. This is in radian measure. So then for the secondary functions, we have the reciprocal of sine is cosecant, and the cosine for secant, so we have to reverse this one, so the 1/2 is 2, and for the square root of 3 over 2 is 2 over square root of 3, because you have to reverse the fraction. So then rationalize the denominator, we come up with a result of 2 square root of 3 over 3. For the tangent, the reciprocal is cotangent, so take the cotangent of 30 degrees, and the answer is square root of 3. Okay, so these are the answers, the 6 trigonometric functions of the 30 degree angle. And take note, this is exact. So our calculator will provide again the estimated value or approximated value. Okay, so for the 60 degree or the pi over 3, take note that pi over 60 degrees is pi over 3. So converting this into radian measure, so we have the pi as pi radian is equivalent to 180 degrees. So degree measure can be cancelled out. Reduce the fraction, becomes pi over 3. Okay, so with that, we can calculate the sine of the 60 degrees. This is our angle, so therefore 1 is our adjacent side, and square root of 3 is our opposite side. Again, this is our hypotenuse. So SOHCAHTOA again, for the sine is opposite, which is square root of 3, and our hypotenuse is 2. So therefore, the sine of 60 degrees is square root of 3 over 2. For the cosine, it is the adjacent over hypotenuse. Our adjacent is 1, and our hypotenuse is 2. Now for the tangent, take note that the tangent of 60 is opposite, which is square root of 3 is to 1. So therefore, the answer is square root of 3. For the secondary functions, the cosecant of 60, we have 2 square root of 3. Just reverse this one. Then take note, we have to rationalize this one. So you have to multiply square root of 3 over square root of 3. So this is 2 square root of 3 divided by 3. And this one is for the cotangent, again, by the way, the secant is 60. and the cotangent is 1, or okay, this must be 1 over square root of 3. This is 1 over square root of 3. So rationalize square root of 3, and the answer is square root of 3 over 3. This is the answer. These are the 6 trigonometric functions. For the cotangent, this is 2. For the secant, and this is 2 square root of 3. For the tangent is square root of 3. For the 60 degrees is 1 half. And for the cosine, or the sine, is square root of 3 over 2. These are the 6 trigonometric functions for the 60-degree special angle, or pi over 3. Okay? So, that's it. So, therefore, so far, we have what? We have the special angles 45 degrees, the 60 or 30 degrees, and the 60 degrees. These are the special angles so far. So therefore, we can always find the what? The exact value for these angles. Okay, so now in order to provide other angles, the exact values for the other angles, we need to study the unit circle principle. Okay, what is unit? From the word unit, means the radius of the circle must be equal to 1. So any circle that has a unit of 1, we call that as a unit circle. Then we can acquire the advantages or benefit about the unit circle using or by providing the exact value of the trigonometric function. So consider the Cartesian, so x, y. So suppose this is our line that coming from the origin. So suppose this is 1 unit. Now if you revolve this 1 unit, where one end of the line is fixed at the origin, so we can create a circle whose radius is 1. So we call it as a unit circle. So therefore, since this is 1, and this is in the first quadrant, so it has, suppose the angle is theta, then with that, we can provide the coordinate. And the coordinate is the x, and the abscissa is x, and the ordinate is y. So this is the coordinate of the point at a radius 1 of the angle theta. Now take note, this theta, depending on the value, so it has the position in the 4 quadrants, the quadrant 1, quadrant 2, quadrant 3, quadrant 4. So therefore, this angle can be increased. So therefore, this side will lay on depending on the value of the theta. So from 0 to 90, this side is in the first quadrant, but 90 to 180 degrees, the side is located in the second quadrant, and between the 180 to 270 degrees in the third quadrant, and 270 degrees to 360 is in the fourth quadrant. So therefore, the coordinate of this point xy will change its sign. It can be positive or negative, or positive or negative, depending on the location. And remember, in the first quadrant, all components are positive. So the x and y are positive. In the second quadrant, the x is negative and the y is positive. In the third quadrant, x is negative, also y is negative. But in the fourth quadrant, x is positive, y is negative. So it depends upon the angle. Okay, so then if we construct a line that passes through, from this point, it drop it, and we have this as 90 degrees. So we can create a right triangle. Okay, so a right triangle whose radius is 1, and one side is y, which is the ordinate, and the abscissa is x, which is the horizontal side of the right triangle. So we have this right triangle with sides x, y, and the hypotenuse 1 with an angle of theta. Okay, so then if we apply the if we take the sine function and the cosine function of the angle, then we can do it because we have the given. So for cosine of theta, x is our adjacent and our hypotenuse is 1, so we have x over 1, which means that the cosine of the angle is just equal to what? X. So this is only true if our hypotenuse is 1, because x divided 1 is x. So therefore, whatever value here will be the sine, cosine function of that angle. So x also, vice versa, is equivalent to the cosine of the angle. Now, if we take sine using this right triangle, it is y over 1, the opposite over the hypotenuse, which means that the sine of theta is equivalent to y. Hence, y is equivalent to the sine of theta. Which means that, again, if this is 1 unit, then it follows that the x actually in this abscissa is just equal to what? It's just equal to the cosine of theta, while your y value is equal to the sine of theta. This is the principle of a unit circle. So for a given distance of one unit with an angle of theta, so we have x and y, then the coordinate at that point, because this is 1, is just simply as the cosine of the angle theta, and the y coordinate is the sine of this angle. So this is very useful in our case. Why? Because if we know that this is 1 unit, then it follows that what? That the cosine of this angle is the abscissa, and the sine is the ordinate of that point. So therefore, for example, if this is 45 degrees, now remember that in our previous, the cosine of 45 degrees is what? The cosine of 45 degrees is square root of 2 over 2. The cosine of 45 degrees, take note, is the cosine of 45 degrees is equal to square root of 2 over 2. And our sine of 45 degrees is also equal to square root of 2 over 2. So again, if this is 45 degrees, then it follows that it has a coordinate of square root of 2 over 2 for the abscissa, and the ordinate is square root of 2 over 2. So these are the coordinate, which means that we can always evaluate the cosine of this angle 45 degrees if we are given the coordinate of that angle, vice versa. Or if you are asked to find what is the sixth trigonometric function of this angle, and you have this coordinate, then we can always provide the values of that functions. Okay, so suppose this is 30 degrees. So if this is 30 degrees, take note, this is pi over 6. So the cosine, take note, the cosine of 30 degrees in our previous lesson in special triangle, this is the same as what? This is the same as square root of 3 over 2. While the sine of 30 degrees is equal to 1/2. So then, since this is 30 degrees, so this must be what? Square root of 3 over 2, and we have the 1/2. That's it. So all are positive because this is located in the first quadrant. Now, if your angle is between 90 to 180 degrees, so suppose this is the angle theta, then this must be the side. Now, if this angle, if the reference angle is 30 degrees, then this must be 1, understood to be 1. Which means that the coordinate of this is square root of 3, which is the cosine, the first element of the coordinate, over 2, and we have 1/2. And take note, this is in the second quadrant, so x must be negative. So with that, what is the By the way, this is if this is 30 degrees, this must be 150 degrees. So if you are asked what is cosine of 150 degrees, the answer is this one. It should be negative square root of 3 over 2. Now in our calculator, the result is 0.866 something. It is an approximate. This one is the exact value. Take note, negative. Now for the sine of 150 degrees, this is equivalent to 1 half. Okay, so remember, if we have cosine. If we have cosine value of the 6 trigonometric functions, we can always provide the tangent. Now, tangent is actually sine of the angle theta over cosine theta. We call this as the uh, uh, quotient identity, which means that the sine over cosine is tangent. So this, which means that if you are given only two functions, that is sine and cosine, we can always provide the 6 trigonometric functions. Now remember that the secondary functions are taken from the primary. So if we have sine, cosine, tangent, the secondary can be easily obtained by reversing its value or inverting its value, or taking the reciprocal of its value. Now, we have the idea that even if we have only sine and cosine, we can always provide the tangent. So therefore, we can always provide the 6 trigonometric functions if given the coordinates of the point at a side distance equal to 1 from the origin. Okay, so very clear that it is not only for the 30 degrees. It is not only for 30 degrees or the 60 degrees or in the 45 degrees. It can be in the first quadrant, in the second quadrant, or it can be in the third quadrant or in the fourth quadrant. Suppose I have the angle. Suppose I have the angle theta is equal to 100, or let us say this is 210 degrees. Okay, suppose this is 210 degrees. So 210 degrees is located in the third quadrant, because in the third quadrant the angles is between 180 to 270. So take note, this straight angle is 180 degrees. So you have to add this by 30. So if this is 30, okay, and this is 30, therefore the total angle or the standard angle is 210. So it has a reference angle. By the way, reference angle is an acute angle measured from either positive or negative x. It is an acute angle. So if our reference angle will fall of 30 degrees, 60 or maybe 45 degrees, then we can always provide the exact value of that 6 trigonometric functions of that angles. Why? Because if this is 30, because this is 30 degrees, so the reference angle is 30 degrees for the angle of 210, then it follows that the coordinate at this point, we can assign this as 1 unit automatically, because this is a special. So only a special angle can provide a 1 hypotenuse side. We call it a unit circle, so we can apply the principle of the unit circle. Take note, the principle of unit circle, if this is 1, we have x. X automatically becomes what? Becomes cosine, and our y is automatically becomes the sine function. That's it. So therefore, in this case, because this is 30 degrees, the acute angle is 30 degrees and is located in the third quadrant, so this must be negative square root of 3 over 2 and negative 1 half, because in the third quadrant all components are negative. Okay, hence that we can always provide the 6 trigonometric functions of the 210 degree. Okay, so Now, if we have this, again, this is 30 degrees, so the 30 degrees again is pi over 6, so it has a component automatically. We can provide this as square root of 3 over 2, and we have 1 half. So, this is 1 unit, because this is special angle. Now, suppose we have 45 degrees. Suppose we have 45 degrees. Now, since 45 degrees is a special angle, so we can provide the distance from the origin or the side. That side can be 1. So, it belongs to the unit circle. So, therefore, take note, for the cosine, the coordinates x and y have the same value with square root of 2 over 2. So, for the angle, take note, the pi over 4, again, is 45 degrees. So, it has a coordinate of what? Square root of 2 over 2 and square root of 2 over 2. Both of them are positive because this is in the first quadrant. Okay? So, therefore, again, this is our cosine of 45 degrees. And this is automatically our sine of 45 degrees. This is the principle of a unit circle. Now, if the angle is 60 degrees, since 60 degrees is a special angle, then we can use the 1 radius, or we can assign that as 1 unit of radius. Hence, since this is 60 degrees, the coordinate must be what? The cosine of 60 is 1 half, and the sine, the cosine of 60 is 1 half, and the sine function is square root of 3 over 2. So therefore, now remember that 60 degrees is pi over 3. So we have 1 half and the square root of 3. You have to memorize this value for the 60 degrees. Take note, for the 30 degrees or pi over 6 we have square root of 3 over 2 and we have the 1 half. So it is actually the reverse. The reverse of this component for the pi over 3 or pi over 6 or 30 degrees is the component of the 60 degrees or the pi over 3 radian measure degree or angle. Okay, now suppose the angle is 135 again. So 100, we know 145, and this is a special angle because again this is 45 degrees. Sorry, this is 45 degrees. This is 45 degrees because 45 plus 135 is 180. This is 180 degrees. So again, this is 45. So we have the square root of 3, square root of 2 over 2 negative, and we have square root of 2 over 2 positive because this is second quadrant. And take note that the 45 degrees is the 135 degrees. 135 degrees converted this to radian measure. So we have pi radian is to 180 degrees. And we can cancel this one, and this will result how much? This is by it is the same as 3 pi over 4. So the reduce of 135 over 180 is 3 pi over 4. So this is it. No? Now take note that negative, the first element, the second element is positive because this is located in the second quadrant. Okay, so for the angle of 180, take note that all terminal sides located in the axes are called quadrantal angles. So quadrantal angles are special. Therefore, the 180 is special. So therefore, we can assign this as 1 unit. So if this is 1 unit, then we can provide the coordinate, and this is negative 1 and 0. So the coordinate at this point is 1 and 0. This is for the angle of pi or 180 degrees. So in other words, this one, the cosine of pi is equivalent to negative 1. So without using calculator, you can do it. And the sine of pi is 0. The sine of pi is 0. Okay? So other quadrantal is we have also the 270. 270 will fall at the negative y-axis. So since it was located in the axis, then this is a special angle. Hence, this must be 1. So it has a coordinate of what? X is 0 and the y is negative 1. So 270 is equivalent to 3 pi over 2. It has a coordinate of 0 and negative 1. So therefore, we can say that what is, for example, the problem is what is cosine of 270 degrees without using calculator? Without using calculator, then all you need to do is what? This is think of the coordinate of a quadrantal angle 270 degrees. It has 0, negative 1. Now the first element, remember, is cosine. So therefore, the answer is 0. Now what is sine of 270 degrees? And the answer is it is negative 1. Now what is the tangent of 270 degrees? Now since we have these values, cosine and sine, then use the quotient rule or quotient formula. Sine of 270 divided by cosine of 270. This is tangent of 270. Now in this case, we have the idea that the sine of 270 is negative 1 and the cosine of 270 is 0. Now remember, we are not allowed to divide a number 0 in numerator. So therefore, this is undefined. This is undefined number. So you cannot, there's no tangent in the y-axis. So therefore, this is indefinite number. It does not exist. While the secondary, the secant of 270 is, this is 0 degrees, so therefore the reciprocal of 0 is undefined also. So there's no secant function for the 270. The reciprocal of sine is cosecant. So we have the value. 2 secant of 270, this is negative 1. Reciprocal of negative 1 is negative 1. That's it. These are the values of the 6 trigonometric functions. By the way, the cotangent, we have the cotangent of 270. The reciprocal of undefined is what? Is 0. So it is a defined number. The reciprocal of undefined is 0. So it can be found in our Cartesian coordinate system. Okay? So these are the examples only. No? We can provide. So it is not only 45 degrees or pi over 4 as the special, 30 degrees, which is pi over 6, or 60 degrees, or this is pi over 3. Now, there are many angles that can be formed from the 45 degrees. So, if your reference angle, by the way, the magnitude of the standard angle is the angle measured from x. So the trigonometric function of that angle standard is the same magnitude, no? Disregard the sign. The same magnitude of the trigonometric function of its reference angle. The reference angle again is an acute angle, means less than 90, measured from it's either x, positive x, or negative x. So take the trigonometric function of that is the same as the trigonometric function of the standard angle, which means that if your reference angle is a special angle, then we can provide the coordinate for the square root of, for the 45 degree square root of 2 over 2, and this is square root of 2 over 2. You have memorized this one. For the pi over 3 or pi over 6, 30 degrees, the greater the denominator, the smaller the angle. So therefore, this must be what? Square root of 3 over 2, and this is 1 half. And for the 60 degrees of the pi over 3, it has a coordinate of 1 half. Okay, 1 half of, and we have square root of 3 over 2. These are the important uh, coordinates in order to obtain the trigonometric functions of the angles related to these special angles. Another thing is quadrantal. Take note. The 90 degrees is equivalent to, it is pi over 2. So pi over 2 is a special angle. So it ends up to what? For the 90 degrees, this is your sine. So therefore, this must be 1 unit because it is a special. So it has a coordinate of what? It has a coordinate of 0x and positive 1. So this is 90 degrees. Okay? So it has a coordinate of 0 and 1. So again, this is cosine and this is sine. Another is, again, this is for the 180 degrees is also a special angle. And this is pi. And it's a coordinate of negative 1 and 0. For 270 again, we had already this value. It is what? This is 3 pi over 2. And we have the coordinate of 0 and negative 1. So we have also the 2 pi, no? The one complete revolution, the 360 degrees is equivalent to 2 pi. So we have the coordinate for the 2 pi or 360 degrees, which is 2 pi, it has a coordinate of 1 and 0, which means that what? What is the sine of 360 degrees? The answer is 0. And what is cosine of 360 degrees? The answer is 1. That's it. Very important are the components of the special angle. So far, for now, we have a lot of angles. Angles that indeed in the axes are quadrantal, so it must be special because we can provide a radius of 1. Now, other than this angle, for example, what is 40 degrees? If the angle is 40 degrees, if this is 40 degrees, if this is 40, the side is only, the angle is 40 degrees, just like this one, 40 degrees, then we cannot assign this as 1 unit because 40 degrees is not a special angle. And this is not related to the special angle. So, therefore, we can only provide the exact value for the enumerated special angles. Okay, here comes the example. Find the sixth trigonometric function of the 135 degree angle. So take note, the six are the primary and secondary. The primary are sine, cosine, tangent. The reciprocals are cosecant, secant, and cotangent. So we need only two. We need only this sine and cosine. Then everything can be solved. The six can be solved because take note that the tangent is sine over cosine. So the best thing to do to answer this one is to plot. Now make sure that you know how much is the reference angle. How much is the reference angle? So remember that if you want to know how much is the reference angle, then you have to plot the 145 degrees. So if you subtract 180 degrees by 135 degrees, because this is in quadrantal, the result is 45 degrees. So this is our reference angle. So the reference angle is a special angle. Hence, the magnitude of the trigonometric function of 145 is the same magnitude of the trigonometric function of the reference angle. So we see magnitude because we disregard, because there are values negative and we have also positive values. So disregard the sign, then they must have the same. Okay, so in this case, the 135 degrees is located in the second quadrant. with a reference angle of what? 45 degrees. So since it's 45, we can assign this as the 1 unit radius. So we can apply the principle of the circle. And it has the coordinate of negative square root of 2 over 2 and square root of 2 over 2. So therefore, we can say that, what are the 6 trigonometric functions? So to answer is, first is, the sine of 135 degrees is square root of 2 over 2. While because this is the sine, take note, this is the sine. And this is our cosine. This is sine of the angle 135. This is the cosine of 135. This is the principle of what? Unit circle. Again, this is cosine because this is 1 unit. Why is it this is 1 unit? Because this is a special angle. And take note, this must be negative because it's located in the first and the second quadrant. Very important is the algebraic sign of the coordinate, because it is where the exact or the value that we are looking for. For the sine of 135, again, the answer is square root of 2. The cosine is negative square root of 2 over 2. And the tangent is to divide the sine over cosine. We can, what? Because they are equal, so therefore the answer is 1. Negative 1 because this is negative, while this one is positive. Different sign. So take the reciprocal of the answer. So we have this square root of 2. Why? Because if you reverse this value, this will become 2 over square root of 2. Then rationalize. The answer is 2 square root of 2 over 2. So we can cancel this 2. So the answer is square root of 2. The reciprocal of cosine is secant. So the secant to 135 is the reverse of they have the same magnitude, but this is sine, negative. Then the reciprocal of negative 1 is also negative 1. These are the answers to the problem. Okay? Now, what else? Suppose I have the angle. Suppose the angle is 5 pi over 3. Give me the 6 trigonometric functions of that. So in this case, take note that you have to plot this one because we want to know how much is where the sides located, because we want to have the algebraic sign of the components of the coordinate. So by the way, is this special? Is this a special? Yes, because this is 3. So this is actually belongs to what? Belongs to the pi over 6, pi over 3 angle. So it must have the coordinate of 1/2 and square root of 3 over 2. Okay? So we need to know the location of this angle because the sign, algebraic sign of these components depending on the location of the quadrant. So in this case, take note that the pi over 3 in the 180 degrees, if you divide the 180 degrees or the pi degree into 3, we have this one as the, this must be 60 degrees. This is also 60 degrees. So 180, this must be 60 degrees. So we have 3 pi. So this one also, if you divide this another 180 degrees, this is 60 degrees. And this is 60 degrees also. And take note the 60 degrees is pi over 3. This is also pi over 3. This is pi over 3. And this is pi over 3. This is also pi over 3. And this is pi over 3. So where is the pi over 3? So count. 5 times. 1, 2, 3, 4, 5. So therefore, our pi over 3 is located in what? In the fourth quadrant. So this must be what? This must be our angle. So this is the 5 pi over 3. Now take note, this is what? The reference angle is pi over 3. So hence, the coordinate of this point, with a 1 unit. This can be 1 unit. It should be what? It should be 1 half 40 pi x, and this is negative square root of 3 over 2 because this is in the fourth quadrant. Hence, with this result, we can say that the sine of 5 pi over 3 is what? Negative square root of 3 over 2. While the cosine of 5 pi over 3 is what? 1 half. These are the answers to the problem. What there are many problems that can be solved using this principle. Okay, so by the way, before we end this video, suppose I have 6 pi over 4. Okay, so what are the 6 degree functions? Now in this case, by the way, the reference angle is not pi over 4 because this is over 4. This is reducible by 2. So therefore, this is 3 pi over 2. So over 2 means what? This is quadrantal angle, and this will end up with what? It's either positive or negative y. But in this case, look at this one. So to locate where is 3 pi over 2, take note this is from 0 pi, this is pi over 2 because this is pi. So therefore, this is what? This is 3 pi over 2 because this is pi over 2 or 90. This is another pi over 2 and this is another pi over 2. So where is the 3 pi over 2? So 3 times by 1, 2, 3. So it will end up in the negative y-axis. So again, this is a special angle because in terms of region, if your denominator is 2 and it is a reduced form, then it is located in the y-axis. Now, suppose I have 12 pi over 3. Now, 12 pi over 3 is what? This is 4 pi. So, where should be the terminal side of the angle? The terminal side of the angle is, this is 1 pi, this is 2 pi, 3 pi, 4 pi. So, this is your 4 pi. Meaning, this will end up in the positive x-axis. If 3 pi, this is 3 pi. So, therefore, this is 6 pi, 2 pi, 8 pi, in the positive x, in the negative x, 5 pi, 3 pi, 7 pi, add numbers before pi signifies negative x-axis for the even positive x-axis. For the fractional denominator 2, if this is add, this will be fall in the negative y. If this is one, by the way, this is, take note, this is pi, no? Pi over 2. This is 3 pi over 2. What next? 3 pi over 2, 4 pi, 5 pi over 2. So this is 5 pi over 2. The next is 5 pi over 2. And this is 7 pi over 2. 7 pi over 2. What next? This is 9 pi over 2. And this is 11 pi over 2. And so on. That's it. So, again, we can always provide the exact trigonometric functions of what? Of the special angles. The special angles are 45 degrees, 30 degrees, 60 degrees. So, any angles that has the reference angle of that angle, and also the quadrantal angles. Angles that end up with the axes. It can be positive or negative y or positive or negative x axis. Okay, so that's it. Thank you for listening.